Bill says there's 4 waiting.
Yeah, it's the same person, so she's joining.
Okay. So maybe
We
we
have a
just go ahead and
total
get started.
14 participants.
Okay. Well, welcome everyone. My name is Jamie Brown Hansen. I'm a member of the team of Biomimicry Switzerland. And it's so great that you all could join us today. We are a network of people in Switzerland and from Switzerland who are enthusiastic about biomimicry, and I assume that if you made it here, then you have an idea of what that is, but in case not, or in case you want to know more, then you're in the right place, because that's what Jacques is going to introduce to us today. So this is the first of 3 webinars that Biomimicry Switzerland is offering over the next month. The team decided to do this now because since as we're trying to design solutions to the situation we're in now, we realize it can be helpful to ask how nature would approach our situation, because when we do that, then we benefit from 3.8 billion years of research and development, so talk about saving time and money. But we can also find strategies that we wouldn't be able to come up with alone as a species, especially at a time where we may be realizing the limits to our own intelligence. And so drawing on a broader and older intelligence from the biological worlds could be very helpful. So Jacques is going to be giving us the talk today. And Jacques, you wanted me to let everybody know that you're going to be recording this and live streaming on YouTube. Yeah.
The live streaming I'm having some challenges, but we're going to record it, so we'll make it available on the YouTube channel or on the website as well. But if that's okay with everyone, we're going to be recording this webinar, as well as all the upcoming webinars as well. So in a couple housekeeping before we get started. First of all, welcome all to this webinar. I'm happy to have you here. You can use the chat and certainly ask questions to bring attention. Either Biljana, Catherine, or Jamie will monitor the chat. And certainly if you have questions that you want to ask during the presentation, you could potentially raise your hand in the chat and I could stop. We want to have a conversation. We certainly will have time to talk at the end. Also, if you're experiencing some audio issue, perhaps turn off your video. That could be one option. If it doesn't resolve, then I would encourage you to call in the number that is listed in the appointment. The audio by phone is a much more higher quality than the audio through the computer. So I will go ahead and start. I'm just going to check if anybody else joined in. So,
in the meantime, Jacques, I'd like to say a few words about you, so everybody knows who you are. Is that okay?
Yeah, please.
Okay. So Jacques is, he's the founder of Biomimicry Switzerland. We've been working together since 2013 when he started the network. He's also a certified biomimicry professional. That's a certification given by Biomimicry 3.8, which is the leading biomimicry consultancy in the world. And those certification programs, they're now accredited as well. So the one he did is equivalent to what is now a master's program at Arizona State University. And then, well, he's from Geneva originally, and now he's the director of student entrepreneurship at the University of California, San Diego, where he's also been an adjunct instructor since 2006. Before that, he was the Innovation and Commercialization Manager for the Biomimicry Institute, and he also had a long, successful career in clean tech for the city of San Diego. So this is who we're going to be listening to today. Thank you, Jacques, for doing the presentation, and also thanks to UCSD for the Zoom account.
You're welcome. Well, welcome, everyone. Welcome to this first webinar series, and we're going to be discussing the essentials of biomimicry. So as it was mentioned before, Biomimicry Switzerland has been around for a few years now. We're an association based in Switzerland with the role of helping spread the meme of biomimicry. Excuse me, I'm trying to admit more people. Late. And sorry to interrupt, but Jamie, if you're the co-host, you could also look at participants and admit them if they're late, please.
Yeah, I'm looking at that, so I'm clicking the button.
Okay, I'll let you do that. Sorry about that. So we are an association based in Switzerland. We're open to anyone who wants to join in. Our focus is mostly around spreading the meme about biomimicry, how we can use nature's intelligence to help solve some of humans' most complex challenges. A lot of it obviously revolve around the idea of sustainability, which is the basis of life. But we're also looking at ways of how biomimicry could apply to other disciplines, such as system, like the economy, or even how we operate as a society. So today, I'm going to walk you through an introduction to biomimicry. And certainly, this is a topic that is much larger, and we usually do over workshops that are potentially a whole day. But hopefully, that will give you a glimpse of what it is, and potentially give you some ideas of how it could be applied. So I'm going to start with this idea of nature, right? We all probably all have a different definitions of what is nature or what is the natural systems. I'm sure if I ask you, all of you who have a chance to spend time in nature, you probably all have different answers. But what we do know is that being outdoor is actually very beneficial to us as humans. There's a lot of studies that shows that the relationship between ourselves and the natural world is very, very strong. And personally, you know, when I go hiking or camping, it's really this idea of relieving myself from this hyper-connected life that we live in cities. You know, you're away from these common noises that we have. You could hear whether it's the water or animals and anything nearby that could be very exciting about it. So it's really this idea of reconnecting, and this is why it's important to us. We also know that being outdoor gives us a lot of positive outcomes. We feel more restored, feel more alive, feel a lot less stress, a lot less depressed, and more focused. I'm sure you all noticed for the last month, globally, you know, a large portion of the population has had to stay indoor. And when you start going outdoor, you actually realize how much of that natural space is essential to your life. Because before, we were so caught up into our own life that we wouldn't have time to stop and realize how beautiful it is to hear a bird or be outdoor in a forest by yourself, away from a busy street. So all that actually is true science, that we know that this is essential to the well-being of a human being. We also have this idea, what's called direct attention. So it is important to keep in mind that the brain, the way it operates, it's really essential to the livelihood and survival of humans. So direct attention really comes to things that are really critical for us to do. So for instance, when you're driving, I'm hoping you all pay attention, because when you're driving, it's essentially, you know, you're moving at a fast speed, you potentially could have unexpected changes happening to you. You have to be on the outlook there on a constant basis. The reality is that you can only drive for so many hours, right? Most people, after 3 hours, 4 hours, their brains start wandering, right? It gets a little bit boring. It gets a little bit tiring. Your eyes start getting sleepy, right? That's why they actually recommend that you need to stop every 2 hours, at least stretch your leg for 15 minutes and do something else. The same analogy could be whether you're working on a computer, if you're working for long hours without taking any breaks, at some point your brain will just no longer function very well. And this has to do with the concepts of, to function properly, your brain needs to focus on important things while blocking other things that are not important, right? So if you think about survival of humans, when we were hunters and gatherers, that was really essential, right? Because there were things out there that could be a threat to humans. There were things that were essential to us, where, for instance, looking for specific food or anything that could be a danger. So this idea of having, for us, ability to focus was essential. It was a survival need, and that requires direct attention. But that also creates direct attention fatigue over time. So what's interesting is certain scenes, certain nature scenes recharge your brain to resume direct attention. So there actually study shows that this capacity for nature to help restore attention is really part of the evolutionary process that we have as humans. So in a way, we were designed to be hyper-focused when we need it, whether it was for hunting or other danger that we had, whether it was a fight or flight type of situation. But we also needed its time to relax. And that's why we all sometimes get mesmerized by things, obviously a beautiful sunset, a sunrise, a beautiful walk into the woods, or things as simple as watching a fire. When you have a bonfire or a fire at your house, at a fireplace, everybody loves to gather around the fire. Everybody loves to look at the fire. Are you getting anything out of it? No. There's nothing you're learning from the fire, but it is beautiful to watch and it's very relaxing. Same thing if you're walking along the beach or other places. So this idea of how we're connected to nature is really an essential part of biomimicry. Humans are not separate from nature. And we also have to remind ourselves that we are not separate from nature, and it's not the environment that we live in, it's our environment. It belongs to all species. We happen to be the dominant species, but that's a different discussion we're going to have in a minute. So being outdoor is a very restorative benefit, right? So if you are working in companies, I encourage, whether it's my students or even people that I consult with, do meetings outside whenever you can. Go take a walk when you can. It's very, very relaxed. Even if you live in a busy street, going to a nearby park away from a built environment type of structure makes a big difference. And there are many studies that show that even in cities where there's more trees, people feel much more happier than in areas where there's no trees. So as I mentioned before, humans haven't changed from an evolutionary standpoint since about 10,000 years ago. This is what your living room looked like about 12,000 years ago. We were hunters and gatherers. We know that because there's still a lot of tribes on the earth that are still kind of using these ancestral habits of living outside. What we also know is that we were much attuned to the environment. There's been studies shows in Africa, for instance, where women would let their children play outdoor, like here in the savannah, knowingly that there will be potentially lions or other threats nearby. And when anthropologists will ask these women from this tribe and says, are you not afraid of potentially your kids being in danger by any kind of wild animals? The woman responded and says, yes, we know, but we pay attention to the cues. We're totally connected to the earth. They would pay attention to birds, they would pay attention to other animals that will indicate something was happening. And that's something that we humans, unfortunately, have lost over the years because we've lived now for the last 400 years in a built environment where we're more and more disconnected from nature. We also live in a linear production model. This is obviously changing, but this is really the basis of all industrial systems today, right? It's a very, very basic system that we're all very familiar with, from extraction to consumption and disposable. We're mostly, as consumers, focused on the consumption aspects, right? Very few of us are very aware of the extraction element. Most economies, at least in the developing world, like Switzerland and elsewhere, 80 to 70% of the GDP is consumption, right? It's just us buying stuff. And that consumption, obviously, as is based from Janine's book and other people out there, it's very energy intensive. It requires a lot of energy. There's a lot of embodied energy, a lot of embodied carbon. And we don't realize that because we don't understand how products are made because we're so far remote from that process. So the industrialization has been something that has been great for us. Access to cheap energy supply has been the basis of how we were able to grow for a 3 billion population to nearly 9 billion. And that's going to continue growing. We also know that this is not ultimately the best route for us because we're running out of not only natural resources, but we're also changing the climate. Also, the pollution itself is spreading in parts of the world that we've never seen before. Things like plastic pollution, which is probably all aware of it, is a growing challenge, right? There's predictions by 2030 or 2050, there could potentially be more plastic in the ocean than there is fish. We also know that in the potable water that you drink every day, because we more and more rely on polyester fibers, we get a lot of that polyester microplastics in our own water that is not filtered today. So these are all things that we're fully aware, but we're very much challenged with. So these great challenges is what also is alarming, but it's also a great opportunity for us to react and really rethink how we could move forward as a society. So when we think of humans, we have to remind ourselves that we're not alone. We happen to be a dominant species that's been around the earth for some time, but many of the elders have been here before us. And we have to remind ourselves that yes, we're the dominant species, and we did colonize pretty much every part of the world, except potentially some of the depth of the ocean that still remain undiscovered. We have a responsibility as a keystone species to preserve the ecosystem for all. Because we know very much that if tomorrow some of these ecosystems collapse, we will collapse. So it's important to remember that the earth will survive no matter what. You know, if tomorrow there's great catastrophe, humans might disappear at some point or be reduced to a short number, but the earth will heal over time. It might take hundreds of thousands of years, but it will. So what is biomimicry? Biomimicry, it's really this idea of practicing lessons from nature to create inventions that are healthier and more sustainable for people. And I want to emphasize on the idea of healthier and more sustainable. We're looking into how nature does certain things to allow us to emulate those principles so that we can come up with solutions that are as equal or follow the same principles as we find in nature. And we'll talk about what they are. Biomimics designers or biomimics focus on this understanding, on learning and emulating the strategies used by living things, right? We're really looking at these creators and try to understand, how is a polar bear able to survive very cold temperature? Or how is an abalone shell is able to be 300 times stronger than any ceramics that we make today, right? So understanding the strategy for surviving, but also adaptation that they have been able to do that over a long period of evolution. But it's important that it's a conscious process. We're being intentional when we do this. Emulation is learning from the living things, then applying those insights to challenges to humans wants to solve. So it's really emulation. We're not talking about copying. We're looking at emulation. And we really also want to recognize the life genius, that many species arrive well before us and they're adapted over time within the constraint of this planet. So not only they were well adapted and they evolved to survive, but they also did it with the constraint of the resources that we have on this planet, that we were subject to the same. So when we think about sustainability on a longer spectrum, a lot of the focus has been on is focused on reducing impact, which is really, really important, right? We want to lessen the impact that we have on certain aspects of products, solutions, or even behaviors. Where we're heading with this idea of biomimicry and other tools out there that are helping you kind of forward-looking your mind to this new area is to look at this idea of regenerative design. We want to be looking at not only ways to restore the environment, but looking at ways that could create a benefit to the earth. So designs that will not only be addressing some challenges that we have today, but ultimately will increase the value that we offer, right? Increase the benefit of ecosystems over time. So if we look at the Earth history, it's also interesting to look at how it's a 4 billion years, how long the Earth has been around approximately. If you compress this into a timeline of a year, this is what it would look like. This is not scientific, just to give you an illustration of what it looks like. So January 1st, if this 4 billion was in one 12 months period, January 1st, the Earth is formed. 25th of February, life appears. Quickly, life realized, instead of relying on gases, we're going to rely on this free power, which is the sun, the photons. So photosynthesis appeared, which is the basis of life on Earth. I mean, I would say 98% of all species rely on photons for energy. Then obviously a lot of things happen in between February, but then we get to multicellular life. That's us, humans and other species. And then November, you have this incredible abundance of new things like fungi, fish, plants, insects. They all appear at that time. And December is the rest: amphibians, reptiles, mammals, birds, and flowers. And I'm asking you, where are the humans on this time frame, right? It's a 4 billion year time frame, right? It's a very, very long time. Well, humans, if you look at all human history, would have taken place the last half hour of the last day. And then if you look at industrial revolution, which is the basis of modern life, it's only would have taken place the last 2 seconds. So this is an illustration to tell us that humans not only are very young as a species, because we're mammals, but we're very young as where we come from, but also the basis of modern life, it's quite short in comparison to the length of the actual of the length of the Earth itself. So 3.8 billion years of continuous R&D evolution, that's what we have today at our disposal. This is all the things that we know out there that are very useful. There's about 300 to 100 million species out there. To be honest, we know probably a lot about 2 to 4 million species. We know a lot about it. The rest, we just know their names. We have no clue about their adaptation strategy. We don't even know much about their genomics. So it's a lot to learn for us. But what we know also is a lot of them are very well adapted design with successful survival strategies. Because when you go outside, remember yourself, because it's a long evolutionary process that we've had on the Earth, where the Earth changed over these 4 billion years. What you have out there, from bacteria to very large mammals like sperm whales, they're the well-adapted species. They're the ones who are able to go through an evolution and continuously adapt themselves to survive to where we are today. So we're really looking at the genius out there, and we should have a lot of respect. Like, for instance, trees are probably the oldest species on Earth. They're super essential to life on Earth, and we don't quite often recognize the benefit of trees. I cannot speak about biomimicry without mentioning Janine Benyus. This is probably the book that has brought a lot of people to this space. That's the book that really brought a lot of light to this space. Janine wrote this book almost 20 years ago, Innovation Inspired by Nature. She's a fantastic biologist, writer, speaker. If you ever want to learn about her, you can watch some of her TED Talks. She's coming up with a new book on nature's patterns. But this is a book that kind of illustrates some of these initial findings. What she was doing at the time, she was just collecting information on innovators out there that was using nature or inspiration from nature to solve human problems. And this is this book kind of brings all that together in some areas, and there's some amazing chapters. So before we go too far into biomimicry, I know a lot of people are really focused around this idea of emulation, right? We look into nature, we understand the biology, we go from biology to design, design to engineering, engineering to potentially creating an actual solution. But there are other elements that we need to keep in mind as well. It's not just emulation. So it starts with what we call the essential elements of biomimicry, the ethos, reconnect, and emulate. So the ethos, it's really the one that I think is as important. It's the reason why you all spending your afternoon here with us and learning about biomimicry. It's the reason why we're here. It's also the reason for those of you that are parents or have grandkids or whoever have niece and nephew, the reason why you want to do good for the earth, the reason why you want to be a good steward to the earth, right? It's the reason why we want to be the guardian of what we see every day. And it's the reason why we want to have the right intention when we use biomimicry for the right purpose. So the ethos is really kind of the why. The reconnect is the one that I'm the most touched by. It's this idea that we cannot learn from nature by just staying at home or learning from a book or watching a video. You got to go out there and experience it yourself. So we all were, I'm sure if you all close your eyes and remember when you were a young child, you were probably mesmerized by everything. I was. I always wanted to touch everything. I wanted to always to ask questions, but I was always fond of observing nature. And I think that's what we want to bring back. And that's what we do at Biomimicry Switzerland, is that we try to bring that element by bringing people outdoor and have them reconnect. So if you want to consult nature, you also have to be in the context of where nature is. And the reason for it is because you cannot understand how a species is able to survive in an ever-changing environment if you don't understand the context where it lives. Also, it's important to think about this idea of isolation from the natural world. There's a lot of research that shows this idea of lack of reconnection. There's actually a fantastic book by Richard Louv, The Last Child in the Woods, that I highly recommend, especially if you have children. He actually quotes this idea of nature deficiency disorder that leads to all kinds of problems in children, but it's actually quite common in adults as well: anxiety, obesity, depressions, and other attention disorder, just because people don't spend time outdoors. So spending time outdoors is essential. And now the emulate, it's really the fun part. It's where everything comes together, because biomimicry is not something you do by yourself. I mean, at Biomimicry Switzerland, we all have incredible disciplines bringing all our knowledge together, because biomimicry as a practice is a multidisciplinary approach. It's bringing biologists at the design table, it's bringing chemists, engineers, designers, business people, other social science, where you all are looking at the problem together and taking the learning from nature and see how you could adapt it to the human perspective of the human challenge. So it's really a collaboration, and that's where it's a beautiful process. And it's not easy because everyone speaks a different language. A biologist would explain something that an engineer would not always understand, and that's the common language has to come, and that's what comes through practice that we offer. We also are based on a water, the earth is a water-based chemistry. Right? You were born in water. Your blood is mostly made of water. The connection to water is extremely high. You know, there's studies that shows that there was a very famous artist that asked people around the world, this is almost, I would say 6 years ago, he asked randomly people around the world to draw a picture of an ideal place. They all drew more or less the same thing. It was near a river or a lake or some sort of water body. It was usually had nearby trees, and it was usually on a higher ground. And if you think about it, water is essential. You could not survive without water for what, 4 days perhaps max, and then your kidneys will fail. You can live without food maybe 3 weeks, 4 weeks for some of us, but the same issue would happen. But water is essential. So we live in a water-based chemistry. Everything in nature is done through water. The catalyst is water, right? Which is really key to keep in mind. We also live in this dynamic non-equilibrium process, right? So this ever-changing context, right? So species have to adapt constantly, right? So that is the best example of that dynamic non-equilibrium is the weather, right? I mean, you could be sunny in the morning and then a few hours later it could be raining. And that's something that plants and everything on Earth have to deal with, right? So water-based chemistry is one of those key ones. Dynamic non-equilibrium is also another one. We also live in the world of limits and boundaries. There's a finite amount of water on the Earth, and there's a finite amount of, if somebody could just mute themselves.
It looks like it's coming from Lars, and for some reason I'm not able to mute him even with the host capacity, but you might be able to.
Okay, sorry about that.
Oh, now he's muted. Okay.
Okay, so yeah, please, as a reminder, mute yourself so that prevent any challenge like that. Thank you. So as I mentioned, we have limits of water, right? It's a finite planet, so there's just so much water on the Earth. Don't create water. I often tell my student the water you drink at some point was in the bladders of dinosaurs, right? The water is the same thing. It hasn't. It just evolved over hundreds of thousands of years. It goes through a hydrologic cycle. Same thing with the atmosphere.
We're still getting some interference. So I'm going to go ahead and mute all. I'm going to try that button, and then I'm going to unmute you. Okay, just a sec.
Okay.
Okay. Jacques, I think you're unmuted again. Now you're unmuted.
I'm unmuted. I'm fine. Can you hear me?
Good. Yep, great.
Okay, so I'm gonna, so we have a finite amount of atmosphere as well on the Earth, and that's what allows us to have this unique life conditions on Earth, right? I mean, this blanket of gases that we have that surrounds the planet allows for a specific temperature. We're changing that gas mixture by adding more CO2 and other challenges, but it's also a finite resource on Earth as well. And that's what you have when you look at other planets, that blanket that covers the planet doesn't exist anymore, like Mars, for instance. We also have this idea of cyclical process, right? So as I mentioned, there's limits and boundaries. It's a water-based conditions. It's also a dynamic non-equilibrium, but it's also cyclical process, right? So on Earth, there's cyclical, whether it's the season, whether it's the tide, all that has specific impacts on species, right? For instance, sea stars that you see on the pictures, they have this unique color because parts of the time of the day they're exposed to the air, right? And that purple color prevents them from UV radiation. They also clumps together because birds would want to try to take a bite of them, which they do sometimes. But by combining themselves close together, they make it harder for the bird to grab one of them. And actually, by the way, if one of the legs gets eaten by a bird, it actually incredibly could regrow itself, right? So very highly adapting model there. The chemistry process in nature is very different than us. As I mentioned before, it's a water-based solution. The catalyst is water, use very simple blocks. It all breaks down to benign constituents, and not very different to us, waste equals nutrients in the habitat, right? So when a leaf breaks down, falls on the ground and breaks down, the nutrients are breaking down by microorganisms and things like mycorrhizal and other things, and eventually are returned back to the soil, and the tree could reuse it over time, right? So this closed loop system is very different. We, on the other side, have a very complex chemistry process. And by no means, I'm saying this has been very helpful to us, right? Some of the most amazing drug discoveries were based on this. But there's a lot of things also that we're aware that these chemicals are essentially poisoning your life, either directly humans or indirectly the ecosystem. So we got to be rethinking around this space of green chemistry. We'll talk about it a little bit about what green chemistry could be. So diving a little bit further into the biomimicry process. So really there are three aspects of how you can enter this space, right? Whether you enter it through looking into a specific form, fitting a function. So in nature, a specific form has a specific function. We could also look at how nature makes structures or assembles materials. So here we're asking the process. How does nature make stuff? And then we also how nature coexists as a system, collaborate, exchange information, work together in a certain way to guarantee the resiliency of the system. That's essential process there. So obviously the picture on the left, on my left, is a honeycomb. Honeycomb are the least amount of resources for the greatest amount of space. This is what bees use as a structure. Not only is very sturdy, but it's very functional. Right? So shape in that specific aspect as a very specific end goal there to create habitat for their young. The picture in the middle, I don't know if you could imagine what that is. Maybe some of you know, but these are spigots of spider spigots, right? So spiders make spider web, and the silk that they're making is really made by each of these spigots. Each spigot makes a different strand that is specific to the spider web. And by the way, this is done at ambient temperature, using ambient pressure, and using raw materials, which is mostly whatever the spider could eat, right? And it's self-assembled, right? The proteins are self-assembled at a very, very low process in terms of energy. And the last one is obviously the coral reef, which we know is kind of the rainforest of the sea, essential to life. It's been around the Earth for more than 450 million years. It's made of calcium carbonate. There is a whole system in there of connecting and creating habitat for the system, but it's also, we know today, that coral reef could communicate. For instance, species of coral reef, until today we don't know how that works, but species of coral reef that could be thousands of miles away from each other will spawn at the same time, at the same day, in the same minute. So it's still we can still not figure out how they do that, but they will exactly figure out when to spawn at the right time. And they would choose different days during the year. It's never the same day. And then when you have the eggs and the sperm being spawning, they only have 30 minutes to match. It's a very short window. So again, something quite amazing. I was mentioning earlier abalone shell, which is something that I'm quite interested in. Incredible structures that we don't know a lot about it. We know that it's 200 times stronger than any ceramics. It is really the way the proteins are assembled, the layers of calcium carbonate are assembled. But the glue into this is really this what's called lustrine A protein that connects these barriers together. This is stronger than ceramics that we make today, 200 times stronger. To make ceramic today, we have such a high embodied energy that it's not even close to what this is done. This is done at low temperature process. So again, very intriguing for us as material scientists to really look into that. So here's some case studies example to kind of illustrate what I'm doing. So that usually helps kind of figure out, well, what are the examples out there of how biomimicry is applied. So here's one that quite relevant today. This is a Galapagos shark. There's many types of sharks. Sharks are fast-moving creatures, not like whales. One thing that was noticed by scientists quite a while ago is nothing would grow on it, right? When you look at a whale, if you've ever been close to a whale, or any kind of slower living creatures in the ocean, you have barnacles, you have anything kind of sticking to the skin, but not in a shark. And they wonder why. And actually, they look closely at the structure of the shark, which is these kind of triangle shape that are at the nanoscale. This is not something you could see. It makes it very rough, if you will. So a company went ahead and say, well, that's an interesting shape. It's an interesting form. That form has a unique ability to prevent or inhibit bacterial growth. So they went ahead and mimicked that structure at the nanoscale. And now they're applying this into medical devices. But they also are actually creating the same material to attach to door handles, to tables. So think about what's going on today with the pandemic that we have globally. This is a way, instead of using chemicals to kill bacteria, we're using surface to inhibit bacteria growth. And the company is called Chocolate Technology. Here's another one. This is one of my favorite organisms that I personally love because I think it's not only interesting, it's called a tardigrade. It's also called a water bear, which I think is because of the claws. A tiny little structure organism that lives in vernal pools. It's pretty fun anywhere on the earth, from the coldest place on the earth to the warmest place on the earth. They live in water pools where they would spawn at a specific time when water reappears. But the unique adaptation of this particular organism is ability to withstand and live without water for potentially more than a decade or potentially longer. And the way it does it is that it removes itself all the water in its body and goes sort of like in hibernation, if you will, and replace that water with a particular protein that will protect all its organs. It could remain dormant a very, very long time. And when water reappears, it will go back to life. And that's what these little guys do. They even took them out of space, brought it back to Earth. They were still surviving. So I think if there's anything that would still be alive way beyond humans, these guys would be extremely, extremely resistant to change. So a company looked at this idea of how can we use this idea of preservations of live materials like DNA. DNA and RNA, it's currently stored at very low temperature. That's how we store these materials. And when we want to reuse it, we have to bring it back to life by bringing slowly the temperature up. It's a very energy intensive process. Same thing with forensics, they use the same technology, or even vaccines. So this technology is actually used in the biotech industry to have an agent and a reagent, right? So you'll be able to put a particular cell, whether it's blood cells, to a dormant stage and then bring it back to a live stage and store them at room temperature. So the company is called Biomimicry, locally based in California. This is another one. This is the orb spider. Unique adaptations. They could adapt in many ways where they're able to create webs that birds could see to UV light. A German company went ahead and said, this is quite amazing because we know bird collision is a huge issue. You may not know, but globally, I think there's probably several billions of birds that die every year of bird collision against buildings. So they create a glass that has these lines built in that are kind of mimicking the orb spider that humans cannot see, but the birds could see. So it's a great way to avoid bird collisions. It's been around for some time. This is another one that I'm a big fan of. When we look at system thinking or system approach, watersheds are amazing because watersheds are not only this body that connects two bodies of water, whether it's the ocean and the river within a large land, which these wetlands are really essential to life. It becomes the main filter for life. Actually, wetlands are considered even more productive than the rainforest because of what they bring, but they're acting as a buffer against high current from the ocean, but they also act as a filtration device from whatever's coming down from the watershed. And they're usually considered the biggest pit stop for birds around the world because that's where they find plentiful of food as they go through their journey of migrations. So this filtration idea was something that brought attention by many researchers. And we know that many parts of the world, we have things like raw sewage, especially in developing countries that are non-treated, right? Which creates all kinds of impact, not only to water quality, health issues, and impact to the environment. So they actually went ahead and developed an idea of building constructed wetland. So the picture on the right is the same concept that you have on the left, where you have basically a combination of gravel, plants, and slowing down the water supply. Instead of having raw sewage that goes through this canal, raw sewage still goes through, but using space and gravel and plants and really slowing down the pace of water, you're going to have plants absorb all these nutrients and clean water. The company that does that is Untitled Ecological Design. So again, when we look at system, we should be looking at how all the system operates at a high level. We know that forests are not only interconnected with each other, but they're also sharing information through the mycorrhizal. This is the mushrooms underneath the soil. This is a discovery that was done maybe the last 15 years. Trees do communicate, do share informations. We also know that older trees, old growth trees help support other trees, right? They share resources and they do that using the mycorrhizal model. They do that to prevent disease. They do that to communicate about potential challenges that are happening within the system. Same thing you could find in the coral reef or the kelp forest. And then many companies are using these principles of nature, of how nature communicates, share resources, and apply it to systems in humans, whether it's the Bank of England looking at ways to prevent the next catastrophe in terms of financial crisis by looking at how viruses communicate, or whether it's telecom companies looking at how tree exchange resources and apply that to algorithm to optimize the use of cell towers. So when we look at biomimicry in nature, there are really two different aspects. There is the linear system, which is changing some aspect, but nature is circular, right? It's all within the same system. We like to be uniform. Nature banks on diversity. Being more diverse leads to more resiliency. We want to build the biggest, the largest nature optimized resources because the bigger is not always the best option. We use embodied energy in many of the processes. Nature uses low energy process in self-assembly. We rely on the cheapest resources that sometimes are potentially scarce. Nature will rely on what's locally sourced, right? Again, the coral reef, it's made of calcium carbonate. These are components that are available in the ocean and in the air, so it's nearby. We're very disposable. Nature is biodegradable, right? And disposable in these days is becoming a bigger word because disposable, even a cell phone is disposable these days, even though they have a lot of resources embedded in there. So we are kind of in that linear thinking straight from using a resource and kind of disposing it. We're doing some recycling, which I think is exactly where we should be heading, and that we should continue doing that. But where we should be heading as a society is this closed loop system. And biomimicry is very much embedded in this idea of circular economy, right? Nature is circular by definition, and learning from nature is applying this idea of how can we reuse waste in a different way. So I'm going to quickly go through some of the examples of how we do this process. So you can go from challenge to biology. So you could start with a specific challenge, like for instance, how do we create a flexible structures, or how do we create a material that is lightweight? So you start with defining the challenge, the context, then you would identify a specific function you want to solve. For instance, it has to be lightweight, it has to be portable, and so on. Then you will actually go into the natural space to look for these discoveries, do some abstraction, brainstorming, and then you will go through the emulation process. And then you want to measure them against the life principle, which we have a workshop in a couple of weeks talking about that more specifically. So that's really challenge to biology. But I think where it's more interesting is when we go from biology to design. When we observe something in nature, a phenomenon that we're not aware of, a unique adaptation that is not aware of, and then try to say, can we use that adaptation that we've learned in nature and adapt it to a problem that we're aware of, right? And so it's a little different process. And keep in mind, the design thinking process in biomimicry is iterative, right? Meaning that it's not just a one time. You may go through that cycle several times until you get it right. So it's all about this idea of lean startup, but also being able to trial and error to lead to the right outcome. Briefly, the life principle, I'm not going to dwell on it too much, but this is what we're going to cover in a couple of weeks. There are principles that were identified by Janine's group 3.8 and Dan Abromeister and a team. There are basically 6 principles that are sub-principles that are really, for us, a template of if we're going to emulate nature, can we incorporate these design principles within our solutions? So evolve to survive, be resource energy efficient, adapt to changing conditions, integrate development with growth, be locally attuned and responsive, and use life-friendly chemistries. They all have very different levels of how you do this, but it's become sort of like a template for us, not only at the design stage, so when we come up with a design brief, but it could also be used as a way to evaluate our outcomes. Did we actually follow nature's principle? And if we not, where do we are missing some of those gaps? So it's a really useful tool. I also quickly want to bring this idea that there are ways out there for you to practice biomimicry. Learning from it is the first step. Getting connected to a community is the second step. But I think the third step is finding ways to really practice this. And there is this global design challenge that's happening every year with the Institute, which Biomimicry Switzerland is part of as a global network. And they have this competition going on. The new beginning of that competition will start in, I believe, in late September, October this year. They just closed the session for 2020. But it is based on the Sustainable Development Goals. So anything that addressed any of these 17 Sustainable Development Goals will be applicable for that competition, right? So you have a chance to apply biomimicry perhaps to education, perhaps to water issues and so on. So it's a very broad area, and Biomimicry Switzerland is here to help you. We've coached and mentored some of the teams over time. There's also a fantastic resource for you to use from the Institute as well that I highly recommend. If you ever wanted to browse the idea of, so how does life create filtration? You can go to this website called asknature.org. It's like a search engine that has already predefined biological strategies, and you could type in how does nature filter, and then it will give you a bunch of examples of already identified strategies, but it also potentially will give you examples of products or solutions that are already out there on the market. There's also, for those of you that are educators, there's the Biomimicry Education Network that I highly recommend. You could join in as an educator, it's free. It's not only a collection of experts that you could join in, but you have access to curriculum, work plans, anything that could help you bring biomimicry in the classroom. And that's something that we also here at the Biomimicry Switzerland, we can help you as well. So at this point, I know we're almost at the top of the hour. I hope I did not speak too fast, but I want to really open it up to questions. And I don't know, I haven't monitored the chat, so I could look it up right now.
No questions yet, Jack. No questions in the chat.
Does anyone has any questions? I mean, don't be shy. You could either type it in the chat, or you could turn on your mic and ask a question.
One question. from Bruno. Bruno, would you like to unmute yourself and ask it?
Yeah, sure, with pleasure. Hello, everyone. Glad to be here. Yeah, I just had a quick question for you, Jacques. I was wondering, whenever you have the opportunity to speak with different institutions, private or public, what are the different outcomes you get from them when you introduce the biomimicry principles, and what are the limitations they see into using these principles for their future operation or actions?
Well, thank you, Bruno, for the question. That's a great question. So it really depends on the institution. So I've worked with very large companies and very small companies. I think it depends on where they are in the spectrum of their own journey. So if it's a company that is already has a strong culture of sustainability, who is looking for ways to do less harm and better good in the future, biomimicry becomes really an interesting tool to explore that, right? So what usually happens is biomimicry is one of the many tools you could use out there as when you're faced with a design challenge that you could use to try to solve a problem. Is it going to solve everything? No. But it does give you this option that instead of going inward by looking at humans' intelligence, which would be an incredible work that we've done over the last 300 years, it's also looking outward and say, is there something we could learn from nature? So I think it really depends on the level of the organization. Now, where I work in an academic institution, it's a little bit more easier to bring this because students are much more open to the idea of trying new things. There's less risk. So biomimicry is much easier accepted. When you're working with an existing companies who has to succeed in making a solution viable, there's a lot of questions that comes to play. Because going from biology to engineering or biology to design is quite hard. We don't have time to talk about it too much, but the truth is it's not an easy step, right? Not only there is a challenge around understanding the biology correctly and translating that correctly, and when I'm saying biology, it's not only the biology, but it's understanding the chemistry, the physics behind it, and then really being able to extrapolate that and figure out, is there a way to replicate those strategies within the human context? And a lot of companies have appetite for this, but a lot of times they're unaware of how to do this, right? So the work that I've done in consulting is that we will help them address some of the broader questions about how to create structures that are lightweight, but yet portable. But when we came to the solutions of how to implement that within the context of where they work, it becomes very difficult to do. So I think biomimicry is a way to bring awareness for companies that want to use it as a way to change their system. They have to have a strong commitment and patience that it would take time. Some of the most successful biomimicry innovation that I've seen over the last decade, roughly would take 7 to 10 years to go from a design idea to a market solution.
Wow. Okay. Thank you, Jacques. Thank you very much.
Other questions? Don't be shy.
I have a question for you, Jack. It's Biliana speaking. Mm-hmm. If one wants to use biomimicry to design a possible solution or to think about a possible solution, where do they start?
So that's a great question. I think again, I would start with the problem. When I work with entrepreneurs, I tell my student that you shouldn't fall in love with your solution. You should fall in love with the problem. So if you fall in love with the problem, and it could be a systemic problem, like obviously like climate change, very complex problem. There's many sub-elements to that. Whatever within that system or that system of climate change you want to address, whether it's a water issue, whether it's a soil regeneration, and you fall in love and you're being curious about it and you really explore it, then you can use biomimicry as a tool to really explore how does nature do it, right? Is there a way, is there some insight there? So the process is really first start with the problem and understanding the problem well, and then really asking yourself, is that problem worth solving? From a societal standpoint, from an economical standpoint, and so on. And then if it does worth solving, then it's like using this biomimicry lens to explore how does nature address this challenge? Does this challenge exist in a natural system? And if it does, what are the strategies and potential patterns you can identify there? So it requires you, essentially, when you want to get on that journey of biomimicry, you have to make new friends. You have to find people out there that are biologists, ecologists, and so on, to help you bring your awareness. You want to spend time out there and observe nature and so on. So your initial journey is really, kind of, if you want to solve something specific, is to understanding the problem. The other one is just being out there. I mean, I tell my students, go out and sit somewhere in nature and observe. Don't judge, just observe and see what comes to you. You may see some interesting patterns. You may notice something that inspires you. Why is this flower this shape? Or why is this, animals moving in a certain way? Or whatever that might be. And your curiosity will lead you to potentially some new discovery.
Thank you so much.
Other questions?
Well, I have another question, if you don't mind, but I don't want to be the only one speaking, so I don't want to take the voice of others. But
go ahead. No, I mean, others are. I mean, as I said earlier, you're welcome to add your questions in the chat if you don't want to speak. But yeah, Bruno, go ahead.
Okay, thank you. When I reflect about our research system, especially in France, I feel like the funds or the grants that are given to researchers are always related to kind of the applications potentials behind it. And I was wondering if tomorrow is the world of biomimicry, is there sufficient research currently made on the topic to support the level of inventions and discovery, or the pace at which it should evolve? Like, do you think there is some gap currently in the way biomimicry operates because of maybe the lack of research or some other part in the process? What's your opinion about that?
That's a great question. Thank you for asking. Yes, I mean, the gap of knowledge is humongous. I mean, the fact that we no longer have even people studying, being naturalists, right? People studying the ecosystems. If you look at the discovery that we have, even in the field of biology, it's very focused on, kind of minute aspect, which is very essential. But when we look at understanding of ecology, generally speaking, is something that we don't understand. So like I mentioned earlier, there's so many species that we are aware of that we don't know a whole lot about it. And when I mean that, by that, we don't even know where they live exactly, how they reproduce, the fitness level they have from a biological standpoint, their adaptations. We don't understand. So there's a great potential just on what we know today, right? This further discovery of biology out there. And then there's probably other species that we're unaware of that does exist, like in the depth of the ocean, that we have no clue. And then the other aspect that we're not aware of is the species that we do know. How are they adapting to the changing condition? The Earth is changing, right? We're all fully aware of that, right? There are things that we could ask our grandparents or elders that will tell us that it's different than it is today. And I think we don't know how this is affecting some of these species. So in Switzerland, there's a lot of species that are in the alpine that, because of the warming of the Earth, either are going to have to adapt or are going to die, right? But we don't understand how they're dealing with that survival process. So to your question, yes, if we're going to support this space of using biology as this next frontiers for us to create a resilient and regenerative world, we need to spend more time, we need to spend more resources. We need to engage people to want to study biology, not to learn from it, but to really learn about it, right? To have a deeper sense of how it works. Because a lot of the research that I've done over the years is we understand some of the basic principles, and when we go deep into how this organism is able to do these amazing adaptations, we don't get it because we don't understand either the physics or the chemistry. Or it's done at a scale like in the nanoscale that we are still unclear. Or as I mentioned before, even at the macro scale, like the coral reef able to spawn at the same time, we still can't explain that. So I think to your point, there's many other things that we need to discover. And I think it's a fantastic opportunity for us. I mean, the research potential for humans is humongous. I would wish that their governments would spend, like we did for the genome project or any other large project around the human body, we would do the same thing for biology, kind of having this massive collective research where we would go out there and really understand the ecological systems and make that available to all.
Jacques, we have a request from Basil. Could you please show the slide chart again? And then Andrea, would you like to unmute yourself and to ask your question?
Yes. Yeah, my question is, it looks like biomimicry is still in the academic world. Mm-hmm. Where are the practitioners who includes biomimicry in everyday life? Because I am very touched with this whole biomimicry. I think it's so huge for my life, for my profession. But I see there is a lot in the computer and maybe abroad, not in Switzerland. And I couldn't find people who really work with this in daily life.
That's a great question. It's still a very young space. Okay. Absolutely right. It's still, I mean, the greatest discovery that I worked, that we all have been exposed at Biomimicry and in other groups, it's really in the realms of academia, right? So there are a few of these outliers out there. There are a few companies in Switzerland that have used biomimicry in developing new products. But the bulk of the research, if you will, it's still very much in academic settings. I would say there's a lot of work done in Switzerland in architecture, in the built environment. So they would use principles of, we didn't have a chance to talk about it, but things of biophilia, which has a lot of basis of biomimicry, or using things like the Living Building Challenge, which has a pedal specific around biomimicry or beauty. So there are subtle spaces where biomimicry has a little bit more of an insight in the practitioner space, but you're right, it's still very much a young space. And to be honest, it's still unproven in the eyes of, how should I say that, kind of the average investors, in a sense, the people that are betting on innovation, they're still seeing biomimicry as this novel idea that still needs to be proving itself. And part of it is because innovation in general is hard. Any things that you ever want to take from an idea all the way to commercialization, it's a long process, which is fantastic, but it's challenging. But if you're on top of that, you're adding the principles of biomimicry going from biology to design, it makes it very, very challenging. But the reality, I think, is as more people are aware of this practice and this tool, hopefully more practitioners out there will try to bring it in within their space, right? So a lot of things that we've talked about today were really product focused, but there are ways where biomimicry is adapted as, so like in the system thinking approach, right? How can we use from a metaphor how nature operates and apply this to the financial system, or apply this to the way cities operate from a government standpoint, right? So there's a lot of that social innovation that is also happening there, but it's much more settled. So I don't know if I answered your question, but that's sort of where we are.
You did, thank you. Just one adding, it's more technical, I recognized, and also for managing social work. I come from this in the healthcare, so it's still, I am really searching for this kind of information and I can't find, but it goes in this direction probably.
I think there's, yeah, sorry to interrupt you.
No?
Sorry. Yeah, I think there's also an awakening happening that has been happening for some time. I mean, the reason why you're all here and the reason why we have this fantastic group of colleagues that I have at Biomimicry Switzerland is because I think there's this higher call that we all have. I think we're fully aware that where we're heading as a society is kind of straight for a wall, if you will. And I think we've heard that story for a long time. What we need to do is a massive turn, right? Whether it's left and right, we need to change course. But I think what biomimicry is inspiring is because it's awakening the sense that we all have as humans, that we're connected to nature and that we're part of nature. That if we would slow down and potentially look at these principles, and I agree with you, some of them are very technical or very difficult to apply, but if we start be willing to rethink even the way we operate business by using some of the principles in biomimicry that we're going to talk about 2 weeks in the life principles, we could slowly change the mindset, right? Moving it from this consumerism society that we're in right now to a much more regenerative society. But also the benefit that I personally have, I know a lot of my colleagues have, is once we understand the value of these incredible organisms, we also have a vested interest to conserve them and protect them, right? Which I think it's a full circle, is at the end of the day, the conservation effort that we've been doing for so long could potentially awaken that need that we don't want to cut down all the old growth forests around the world because there's so much unknown that we're not aware of. Same thing with, these indigenous communities. We need to protect them, their culture, their language, their know-how, because they also know how to take care of that land that we're not aware of. Right? So I think there's this broader awakening that I think is happening, and I'm actually very pleased. I'm seeing this with young children, but I think this group and many generations are kind of coming to that. But it is a process, right? So everybody will intervene in that system depending on where they come from, and we are going to make an impact. And right now there are some interesting research going on around the pandemic. We're all looking at how to make a vaccine, which is extremely important. But this was mentioned by a webinar last week from Janine Banyers that she gave to the Institute. She was saying only a few scientists are looking at how bats are known to have COVID-19 or coronavirus in their bloodstream. But for some reason, bats and many other animals are able to disable the virus within themselves. So there are a few scientists that are looking at, or if bats are able to do that, can we potentially understand how they do that? So we can apply that to humans, right? So it's a whole new space. We have to shift the paradigm in how we look at problems in general. Sorry for the long answer.
Thank you very much.
We have a request from Jerome. He would like you to please show again the biomimicry definition slide. And then Oracula, would you like to unmute yourself and ask your question, please? Raluca.
Yes.
I'm sorry.
Raluca. Hello, everyone. I hope you can hear me.
Yes, we can.
I am interested if I was wondering if you know of any school or school system that is trying to include the biomimicry principles, when to enhance education and.
That's a great question. Thank you for asking.
Sorry.
No, sorry to interrupt. So I think it's a great question, and I think it depends at what level. So at the university level, I think a lot of universities either touch on this subject of biomimicry. So biomimicry also has different names. Just to be, and I didn't have a chance to go with. I refer in the work that I do bio and star because there are many cousins of biomimicry, if you will. So it is used at the university level. In space like material science, there is a whole space looking at biology and material science, computer science, and so on. So at the university level, there are definitely people either doing research or having some courses that are related to that subject. When you go to the lower grades, in Switzerland, and I will let some other of my colleagues join in, there are at the high school level more and more interest to bring in the curriculum elements of science that involves ecology, but also entrepreneurship and solving problems that are more sustainable. So there is this aspect there. There are programs that does exist around the world. There are programs in Europe that offers training on this subject, but university per se, you know, as far as I know, I think there are in the University of Utrecht in the Netherlands, who has actual well-defined programs. I know that at some point in Switzerland, the EPFL had not so much courses specific, but they had a lot of electives around this subject. I know the EPFL, the political school in Zurich also had the similar things. But there are programs in the US who has a lot of these embedded programs in it. It still remains a new things, but I think in the coming years, we're going to see more and more that done at the lower grade, whether it's middle schools and high school. We'll see more and more curriculum created around this. And then university level, I think you'll see potentially like the University of Utrecht master's program and PhD program. So France also has, I think, some PhD program that I'm aware of.
But it's not, I'm sorry, it's not, my question is not so much about courses and curriculum that maybe would exist. It's more about if there is a school that is organizing itself and everything it does somehow like nature does, you know, in that sense. So
you mean like a school system or a school that actually uses nature's principles and how it operates?
Exactly. Yeah, exactly.
That's a really,
yes.
So that's a really good question. And I'm blanking. There is a school that has, I'm happy, and I'll give you an email address in a second. I'm actually going to bring that slide in a second. But there is a middle school in the US that has some of these principles around this idea of connecting with nature, and I'm blanking on the name of the school right now. It will come back as soon as we end this webinar. But I'm aware of one. But
Okay.
I will let anybody on the Biomimicry System team to chime in if you have any points you want to add to this. But I will show you. So just quickly, these are the other webinars that we have coming up. So on June 11, we have one on the life principles, which is, I hope you guys could join us. And then the last one that we're going to have is what nature teaches about resilient society, which I think will be a fantastic. This is one of the advisory board member who will give this talk. And then obviously you can reach us on the website. And if you have questions, you could reach us on the email listed there, and also any other elements, YouTube, Facebook, and Eventbrite. So I'll be happy to think about it if I remember. You can email me to remind me, and I'll look for that name.
Thank you.
Any other questions?
Not in the chat.
Okay, I have a poll. You don't have to answer it, but there are 3 questions. I just want you to rate this webinar. So I'm going to launch the poll. Go ahead and rate it. This is for us. You know, we want to get a sense of how it works. So if you want to take the time to answer the poll, that'd be great. I'll give you a few more seconds. Got one more person. Okay, well, it looks like this was helpful. And certainly keep in mind that, you know, this this is done over an hour. We usually do these things, when we talk about this subject, it's not just a lecture type. We have usually do this for an entire day. And somebody else. Thank you for answering the poll. But yeah, usually we do this for an entire day, and we have more ways for you to practice the knowledge that we give you, right? So a lot of things that I talked about, you have a way for you to adapt it and learn on your own. So that's an interesting aspect. If you have no other questions, like I said, I hope you can join us on June 11. And it was a great pleasure to share this webinar with you. I want to thank my team, my colleagues, Jamie, Catherine, and Liliana for helping us put this together. And we're all here to answer any questions. So feel free to let us know if you have more questions, and reach us directly on via email or through the website. And you're welcome to also check our website. We'll put the recording there as well for those that were not able to attend, as well on the YouTube channel. And as I mentioned, if you're interested to learn more about what we do, you could attend one of our monthly meetings in the next coming weeks. Thank you.
Thank you, Jacques.
Thank you, Jamie.
Thank you to everyone for joining. Have a great evening.
Thank you. I'm going to stop the recording now.